Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the target compound and work backward. The final product is isobenzofuran 1,3-H1, also called phthalide or 1,3-dehydroisobenzofuran 1-1, which is a bicyclic compound consisting of a benzene ring fused to a 5-membered lactone, cyclic ester, ring. Moving on to the next step. Identify compound Y. Y is formed from X by treatment with H+ and heat, acid-catalyzed lactonization cyclization. For Y to cyclase to phthalide under acidic conditions, Y must be 2-hydroxymethyl benzoic acid or its equivalent, a compound with a carboxylic acid and a hydroxymethyl group ortho to each other on a benzene ring. Under H+ heat, the of the CH2O attacks the carboxylic acid to form the lactone ring. Moving on to the next step. Identify compound X. X is converted to Y by treatment with concentrated KOH. If X is ortho-bis hydroxymethyl benzene, i. 1,2-bis hydroxymethyl benzene, KOH could perform a Cannizzaro type or oxidation reduction reaction. However, looking more carefully, X must be a compound that upon treatment with conc. KOH gives a compound with both a CoO or carboxylate and a CH2O group ortho on a benzene ring. Actually, working from option A ortho-bis hydroxymethyl cyclohexadiene, which is essentially the cyclohexadiene non-aromatic form with 2 CH2O groups ortho to each other. Treatment with 2 moles of PCC in CH2Cl to oxidize both primary alcohols, one CH2O and the other CH2O, giving orthophthalealdehyde, benzene 1,2-decarbaldehyde. Wait, but PCC oxidize primary alcohols to aldehydes. Re-examining option A shows ortho-bis hydroxymethyl benzene reacted with 2 moles PCC. 2 moles PCC would oxidize both CH2O groups to CHO groups, giving phthalealdehyde to formylbenzaldehyde benzene 1,2-decarbaldehyde. This is compound X. And for the final step, confirm X, Y product. X is equal to phthalealdehyde. Treatment with conc. KOH, a Cannizzaro reaction occurs between the 2 aldehyde groups intramolecularly or intermolecularly. The intramolecular Cannizzaro reaction of phthalealdehyde with KOH gives the potassium salt of 2-hydroxymethyl benzoate, i.e., Y is equal to 2-hydroxymethyl benzoic acid after acidification. Then Y under H+ heat undergoes lactonization to give phthalide. This is consistent. Why other options fail? B. 2 moles DBLH on a diester ketone substrate would give different reduction products, not leading cleanly to X is equal to phthalealdehyde. C. 2H2PD BaSO4, Rosenmund conditions, on diacid chloride would give dialdehyde, but the substrate shown has an acid chloride and a CH2COCl, not a simple acyl chloride, giving a different product. D. CH3NGBr on a ketone gives a tertiary alcohol, not an aldehyde needed for X. Therefore, the correct answer is A. Therefore, the correct answer is option A.